The night sky does not always feel like a comfort. There is a version of the far future where you step outside and find almost nothing up there. No Milky Way band, no nearby galaxies, no clusters, only a thin dusting of faint red embers, stretched and cooled by expansion, drifting toward a darkness that no telescope can ever cut through. In that distant epoch, anyone still alive would see a universe that looks abandoned. No signs of a beginning, no clues that there was ever a Big Bang, just a cold void that appears eternal and empty. From another point of view, though, that same sky looks like something else. It looks like the final stages of a colossal gravitational collapse stretched out over unimaginable time. Every galaxy, every star, every atom falling deeper into an invisible throat in space-time. That is the unsettling idea some physicists have been entertaining for years, not as a horror story, as math. As a serious attempt to understand what a black hole really is. And lately, as new data has poured in from telescopes like James Webb, that idea has started to feel less like a late-night thought experiment and more like a quiet, persistent possibility. The possibility that our entire universe is already inside a black hole. To understand how disturbing that really is, it helps to remember what a black hole is in the first place. In the standard story, you start with a very massive star. It burns through its fuel, loses the outward pressure that held it up, and then gravity wins. The core collapses inward, crushing atoms, then nuclei, then the very structure of space-time around them. If the mass is high enough, escape speed at the surface becomes greater than the speed of light. That point of no return is called the event horizon. Cross it, and there is no path that leads back out, not even for light. In classical general relativity, deep inside that horizon, the collapse continues until the equations predict a singularity, a point where density becomes infinite, curvature becomes infinite, and the theory stops making sense. This is the part physicists do not trust. Infinite values are usually a sign that a theory has been pushed beyond its domain. Still, as far as Einstein's equations are concerned, something catastrophic lives there. There is a strange rule that rides alongside this story. It is called the cosmic censorship hypothesis. Roughly, it says that nature hides naked singularities behind horizons. The most violent tears in space-time are always covered, like a wound under a bandage, so that the rest of the universe never has to look directly at them. From the outside, then, a black hole is a dark sphere with a surface you can never reach and a center you can never see. A region where time slows down for infalling objects, where light curves back on itself, where information appears to vanish. But that is only the outside view. If you follow the math inside the event horizon of the simplest kind of black hole, something odd happens. Coordinates switch roles, space and time trade jobs. Moving inward becomes less like walking across a room and more like moving forward in time itself. You are carried along by the geometry, with no way to stand still or go back. And when you write down the equations for that interior region, they start to look unfamiliar in a very familiar way. They begin to resemble the equations that describe an expanding universe, the same kind of universe we live in now. It is here that the nightmare begins to change shape. Black hole cosmology is the name given to a family of ideas built around one central move. Take that interior solution of a black hole,
the part beyond the event horizon, and treat it not as a tiny region inside a bigger universe, but as an entire universe in its own right. In some versions of this picture, a black hole forms in a parent universe. As matter collapses and crosses the horizon, the interior begins to evolve with its own time, its own notion of distance, its own cosmic history. From inside, observers see a universe that appears to be expanding from a hot, dense beginning. From outside, all anyone ever sees is a black hole with some mass, some spin, some charge. Physicists like Damien Eson and Robert Brandenberger explored models where a universe emerges from a black hole interior, and they realized something intriguing. The interior universe can naturally address some of the classic cosmological puzzles: why the cosmos looks so uniform in every direction, why its geometry is so close to flat, how structures can form in the way we observe, sometimes without relying on a long period of inflation in the usual sense. Later work suggested even more dramatic twists. Instead of a universe starting from a singular Big Bang, some models propose a gravitational bounce inside a black hole. In these scenarios, matter collapses toward the singularity, but quantum effects or new physics at extreme density cause a rebound. The collapse turns into expansion. A new universe inflates from the ashes of a dead star in another cosmos. From the perspective of the interior, there is no sign that any of this is happening. You do not see a wall. You do not see a black sphere. You see galaxies receding, background radiation cooling, structures forming and dissolving. You see a cosmos that looks, in many ways, exactly like ours. From the perspective of the exterior, all of that drama is sealed behind an event horizon that never lets light escape. These ideas began as elegant exercises in geometry, ways to see how far Einstein's equations could be pushed. For a long time, they sat on the edge of mainstream cosmology, intriguing but untested. Then, the sky changed. When the James Webb Telescope opened its golden eye, astronomers expected surprises. They didn't quite expect how quickly the surprises would arrive. Within its first campaigns, Webb started to reveal galaxies and black holes that appeared fully formed far earlier in cosmic history than simple models predicted. Some quasars looked enormous when the universe was only a few 100 million years old. Others appeared to host black holes millions or even billions of times the mass of the Sun, in an era when there shouldn't have been enough time to grow them through ordinary processes. To explain these observations, cosmologists have been exploring the idea of direct collapse black holes. Instead of forming from dead stars, these monsters might arise when pristine gas clouds collapse directly under gravity into massive black holes, bypassing the usual stellar stage. Webb has uncovered promising candidates that fit this picture. The details are still under debate. Mass estimates are tricky, models are being refined, but the general pattern is clear. The early universe seems to host structures that look uncomfortably mature. Massive black holes, bright organized galaxies, quasars blazing long before there should have been enough time to build them. From the point of view of standard cosmology, this is not a fatal blow. The Big Bang plus dark matter plus dark energy still fits most of the data beautifully. The new discoveries push the models, but they don't break them. Astronomers are hard at work updating formation scenarios, adding new physical ingredients, exploring how fast black holes can really grow. From the point of view of black hole cosmology, though, the site of early massive structures has a different flavor. In a universe born inside a black hole, the initial conditions may be imprinted by the collapse that formed it. The parent black hole is already a dense, highly curved region of space-time. The interior can inherit that density in a way that might make massive early structures more natural. New work even explores how a gravitational bounce inside a black hole could seed the kind of rapid early formation Webb seems to be seeing. This doesn't mean we can simply point at a Webb image and declare that we live in a black hole. It does mean that the data, instead of dismissing the idea outright, quietly leave a door unlocked. And the sky is not finished with its hints.
Bring your attention back to the night sky above your own world. Right now, in this era, the universe still feels busy. Galaxies fill the deep images. The cosmic microwave background still hums faintly across the sky. We can point telescopes like Webb toward the early cosmos and catch light that has been traveling for more than 13 billion years. We can, for the moment, still see hints of a beginning. If the standard picture is right, that beginning was a hot, dense phase that started everything. If the black hole cosmology picture is right, that beginning may have been the inside of a larger collapse, shielded by a horizon we will never detect from here. Either way, the story is not one of endless open possibilities. It is a one-way evolution through space-time. Entropy climbs, stars exhaust their fuel, black holes grow, the sky thins, the future narrows. The disturbing part is not that we might be stuck inside a black hole. The disturbing part is that even if we are not, the universe is already a kind of inescapable interior, a finite region of time and space with a beginning, an evolution, and an end that no structure inside it can avoid. The theory that we live inside a black hole simply lays that feeling bare. It says that every breath you take, every memory you form, every civilization that rises and falls is written along a path that was always bending inward. At some inconceivably distant moment, long after the last star has died, long after the last black hole has evaporated or merged, the geometry that allowed you to exist will run out of future. Whatever lies beyond that point sits behind a horizon you were never meant to cross. And as you stand under tonight's sky, with its familiar constellations and bright, reassuring band of the Milky Way, that possibility quietly sits behind everything. The possibility that the edge of reality already surrounds you. If you want to keep walking along that edge, there is always another theory waiting in the dark.